Hi, um, welcome to our webinar today. So my name is Maxime Lemaitre-Brassard, and I am co-founder at Lima Charlie. Today what we wanted to do was to cover a topic that we haven't really covered in the past, which is the advanced DNR rules. So as Lima Charlie has a big focus on infrastructure. Meaning, we bring you the Pro Tools that you are able to use and integrate in your soccer and your operations. And part of that means that we want to provide you with a really robust rules engine that will allow you to customize exactly the types of detections that you are doing. So, what that means is that this rules engine is reused in a few different places in Lima Charlie, and really the plan is for it to be reused everywhere in Lima Charlie, so for it to be one language of automation. We tried to make it fairly easy to create easy rules, easy automation, but there's also a ton of power that goes behind in the engine that may not be so obvious as a first take. So today is really kind of our attempt to try to communicate that better and show you, and kind of, some of those might require a specific understanding of them to really be able to leverage it. So let's get into that today. We will start by going over the very basics of the rule, and this is not going to be kind of an introduction to DNR rules. The goal is really for anyone who is not that familiar with the rules, so that you're not completely lost and you get something out of this. But we'll kind of go fairly quickly over that part of things. I will be happy to take questions, and I have some colleagues as well in the channel who will be able to take questions and reply as we go. Towards the end, I will go and answer any other questions. Obviously, as you probably know, we're very easy to reach in our Slack channel, as well as our website, or by email or anything like that. So don't hesitate there. And the usual disclaimer is that there's a certain lag in this webinar. So I think I'm about 20 seconds in front of everybody. So if I take a little bit to respond, that's what's going on. All right. So let's get started. So to do this, we will start with kind of the intro I mentioned a little bit. So I have a little bit of a plan here, and we will be going between this plan, some kind of concrete examples, as well as the documentation. So just to begin with, again, the fundamentals of what's going on here. So the DNR rules apply to JSON, and they are designed to be, generally speaking, generic. So you'll see that we apply them to a bunch of different things, or they can be applied to a bunch of different things. And then we have specialized operators within those rules that will allow you to, kind of go the extra mile, or be more specialized in certain circumstances, like against endpoint telemetry. By default, when we're talking about a DNR rule, we're talking about one event is being analyzed by one rule at a time. And so when you're thinking about the structure of a rule, it's always, here's an event, here's the rule, does this match? When there is a match for the rule, an action will be taken. So we usually have two sides of a rule. So the matching side and then the response side. So if an event matches, then we respond. Kind of going briefly over what we can run on. So we have endpoint events. This is just going to give you a little bit of an image around this. So this is the JSON you get in Lima Charlie if you're getting events. So you will have a routing component that will have information about where this event is coming from, what type it is, external, internal IP, all that stuff. And then you will have an event component that is really the payload of this event, what's going on. But we have other interesting bits. So we can apply DNR rules to artifacts. So artifacts in Lima Charlie tend to be, very eclectic set of things, from Windows logs to sys logs to prefetch files or memory dumps, and PCAPs and Zeek logs. So everything that's kind of external to the agent itself, generating kind of its own data. So in the artifacts, we will normalize everything coming in, and convert it to JSON as much as possible as it comes in. So I believe this is I think this is a Zeek log entry that's coming. So this is just an example of one, log entry from Zeek. And because DNR rules apply to JSON, we'll be able to go over that as well. But we also have deployment events. So the deployment events will be events that are generated internally to Lima Charlie. Let's say in this example, it's when my bad. I will reshape this. So an enrollment, when a sensor enrolls in Lima Charlie, we will produce a deployment event that has a little bit of information around it. So it's kind of life cycle things in Lima Charlie. And you're able to build rules that operate on that. So you could, let's say, automate an initial survey, or maybe you have your own special, payload that you want to run on new endpoints that enroll. This is an event that you can set up and automate all that process. Finally, we have the artifact events, which are kind of different than the artifact itself. So the artifact is, I get a Windows event log, I convert it to JSON, and then I put my rules on the content. The artifact events are events that are generated to let you know that something has occurred with regards to an artifact. So not the content itself, but like the metadata around it. So in this example, we're saying, hey, a PCAP just got ingested as an artifact. If you want to do something from that, maybe you want to apply special logic, maybe you want to go and download it, you can use that. So as you hopefully know, but the detection, the DNR rules are kind of structured as a logic tree, right? So if you've taken computer science before, or you think of it as a logic tree where, every node you make a call, does this match, yes or no, where you can end or various clauses. This is what it looks like. I'll show a little bit more. The response is just a list of things to do if the matching part was successful. And we also have things like, I won't get into it, but things like false positive rules that use the same engine, but that get applied to the detections themselves. So let's say you have a DNR rule that produces a detection. You have another layer of rules called false positive rules, where you can say, you know what, if I ever see a detection that contains, my other agent.exe, I want to ignore it. So you can do that there. The way that we target the different types of events that I mentioned above, again, uses targets. And we have a bit more in the documentation. We'll actually go a little bit over that. All right, so let's take a very quick look at the structure. So this is a very basic structure here. I just wanted to kind of put this on paper because what we're talking about is YAML, right? And the rules are generally structured as YAML or JSON, so equivalents. And this is kind of the idea when we mentioned the logic tree aspect. So you'll see that sometimes we'll have a node, and you'll see what that looks like as AND, and then you have different operators. So this ANDs all the operators below. This OR would OR these. So if one of these is true, then this is the whole thing is true here. And then if 1, 2, and 3 or 4 are true, then we match at the end. So, it's something that makes sense fairly quickly as soon as you start using it. All right. So let's go back and get into a little bit more of the meat. So we're still kind of what I consider into the basics. So we'll still go fairly quickly. But what we're talking about here is the basic rules, which are stateless. So you'll see we'll use the word stateless and stateful. Um, Stateless goes again at kind of one of the early statements I made, which is when one event comes in, we operate, we take one rule, evaluate whether there's a match or not. So that's stateless in that the next event that comes along and I evaluate it, my rule doesn't remember anything about the previous event. It's one event at a time. The stateful, which we'll get into the advanced section, is when we start to say, you know what, I know that this is data, let's say, from an endpoint, and I know there's a state to an endpoint. Like there's parent processes, child, and relationship between events. I want to define a behavior to look for that is stateful, meaning I want my rule to remember what's going on that particular box, not just go one at a time. So going back to the stateless, here's a very basic example of a rule like that. So it's a pretty simple rule. You'll see that we kind of have the two components here. So this is a response. This is the lookup. And the operator, every single node has an operator, in this case, lookup. So we're saying I want to look for a specific value that's in my event. I want to look against some kind of list somewhere, whether that value is in that list. What I'm describing is a threat feed, right? Generally speaking. Oh. Okay, sorry, I think I disconnected for a second. So this is a threat feed as we would generally describe it. In this case, right, lookup, I'm saying I'm interested only in the events that are network connections. And I will look them up against a resource. So you'll see this coming fairly often, LCR, literally resource. And it's lookup, which is kind of like a threat feed, but we don't make a judgment call about what's in there. You could have a list of known domain names that you want to whitelist. That'd be fine. You could use that as well. And then lookup, and then Alien Vault IP reputation, which is a resource that we mirror from Alien Vault. It's a free public resource, so we mirror it within Lima Charlie. And what do I want to look up in that resource is whatever is at this path within the event. So that will be event/network activity something. So this is basic pattern matching, kind of you might have seen before, not full regular expression. So we're saying network activity something, and then an IP address. If I go and you'll see this coming up in more complex examples as we keep going. The response is a list of so it's a list of actions that we want to take in response to this. So in this case, we're saying report, which is generate a detection, generate an alert, and we will call it Alien Vault IP reputation. Could be anything. So that's kind of a very quick, basic example of a stateless rule, right? Here, what this rule is saying is, hey, is this a network connections? No, move on. Yes, okay. Does this contain that? Very, very basic. So let's keep moving a little bit. We have a ton of operators. So those operators, let's switch to the documentation. Here we go. So go to doc.limacharlie.io, the Lima Charlie documentation. Here we go. And in our case, we'll go into the detection and response section for the reference. And you'll see that everything that I'm talking about here is kind of documented in here. We'll go over, the targets, but also over, the basic structure. You'll see some JSON sometimes. Um, the logical operations that we have, and all of the actual operators. If I keep going a little bit, you see here in the operator section, we have and or. We talk about every one of them. Matches for regular expression, the Levenstein distance for string distance. There's a ton there. I won't go into kind of everyone individually. They are, each one kind of on its own is fairly simple. It's really how you assemble them, right? So what I'll move on is to the intermediary kind of concept that we have here. So the first one I talked about a little bit already, which is the resources, um, and yeah. So the Lima Charlie resources, which will allow you to kind of push your own thread feeds to the cloud. You use the lookup operator to look against it. So I think this is actually, you're going to see a ton of examples that we have. It tends to be fairly straightforward. So the more interesting example concepts are the look back. So now we're kind of entering really the intermediary aspect of things. So these are getting a little bit more advanced. So as part of a rule, when you create a rule, sometimes you want to compare a value. Let's say I want to say, if evil.exe, if the file path of my new process ends with evil.exe, do something. So that's fairly easy. That's fairly straightforward. In a normal rule, right, you would have the path that goes to event file path, and then you'd go to the value, which you would say evil.exe. Sometimes, however, you want to compare two things that are within the same event. So you don't want to say evil.exe. You want to say if the file path, ends with a value that's also found at another spot in the event, or you will say that as part of your response, right? I want to kill the process that I'm looking at here. Well, if I'm giving a response of whatever it is, I think OS process kill, or deny tree, which tends to be a bit better. I can't put a specific value because I don't know. This is at runtime, right? What I want to do is I want to tell the DNR rule engine to go and take the value from the event itself and kind of paste it in what I'm doing here. That is called the look back. So the look back is pretty simple. So you will see that wherever we would have a value, let's say it's a process kill, and I'll write up an example. Actually, let's do that now. So I'm going to copy this, and we're going to move to a new file. Pardon me. This.json. Okay, so I will switch back to his code. There we go. All right, so we have our example here. So I took an example event that we had before, and what I'll do is I'll copy it below. Right, as I was saying, I might have a response that is, action, task, and then sorry, I actually sometimes it slips out of my mind. So command, I could say deny tree, And here, well, I want to kill, the process that I have above, but I can't, put anything specific because again, at runtime, it won't be good. So what I'll do is I'll put the look back, which uses these angle brackets. And what I put in between those is going to be the path in the event of what it is I want to kill. So here I could say that it is in, so this is a kind of a subset a little bit, but in event process ID. So if I put this here, what I'm telling the engine is that I want to go and I want to issue the deny tree command. But what I want to put as its argument, right? This is a command line of just like you would go live interacting with a sensor. You would have you would say, okay, go in the event, which, is this / process ID. So take the process ID and I want to use that. So this is a bit of a, fictitious example. There's, the process tree, I think, takes a slightly different argument. I think you would have to go and say something like PID and then do something. But the idea is that. So it will allow you to refer to things in the process. You can use this in a bunch of different places, whether it's in the response or as part of some detection. So sometimes in the detection itself, you'll want to actually do that, refer to another spot. One gotcha to be careful about is that we will only interpret the lookbacks when it's its own token. So there's a shorter version of this response here that I could have done, which is to just put it as one line, right? So I could do this. But if I do that, I cannot put a look back here. So if you want to use a look back, you'll have to use the tokenized version here of the command. So that is what a look back is. I think we have some good examples in the doc. If we go back briefly. So, good examples here, like event, question mark, username. So here I'll go in my event. Question mark will say, okay, look for something. So I will, one level of depth. So I'll go in at parent and username. So I'll go and I'll find username. So Maxim. So you can see a couple of examples here. The next intermediary concept is the one of variables. So variables are a way to keep a little bit of that state, right? So I mentioned earlier, all of this is stateless, right? So far, we've gone one event at a time. Sometimes there's bits of information that you do want to keep it, across state, and the variables are kind of the cheating way of doing it in a fairly basic way. So they will allow you to take a piece of data from an event and record it for later use by the same or different rules. So I'll be able to set this variable, add this variable. I'll give it a name, and the DNR engine will remember this for I think for quite a long period of time, and across reconnects, across all of that stuff. And it will not just keep that one variable, but you can keep multiple values for that variable name. So all of the logic later on that you'll see will look at not just if a variable is equal to a specific value, but if one of the values in this variable is equal to this. You'll see it will make more sense as we step through the example. So let's go at this example. This is kind of the canonical example here. I have two rules. And what I want to detect is the there's a name for the rubber ducky, or the rubber ducky attack or something. Funny name. So the idea is I want to detect things that are executing, that are unsigned, but they're executing out of a removable drive. So here's how that's done. So we have got two rules. The first one is we're saying, well, I want to record which drives are getting plugged in, which ones are external volumes, because I mean sometimes it might be pretty straightforward in your company. Hopefully, if you're mapping things very clearly, but sometimes you just don't know. Drives kind of pop in various spots, and we're trying to kind of do this the easy way. So here we're saying I want to detect an event that's volume mount. Fairly straightforward on Windows. Again, that's as simple as it gets really for DNR rules. The part that's interesting is the response component. So I want to add a variable. The variable name is going to be called external volumes. And here I will use a lookback, as we just saw. So what this is saying is it's going to take the volume mount event. And that event contains, we can go in the doc, and we have examples of like all those events. It will contain a volume path, pretty straightforward. So that's going to be like, E colon. And we're going to take that value because we just saw a new volume mounting. So at runtime, so we're kind of assuming that this is some form of removable drive or network drive or something like that, and we will add it to the external volumes. So as I mentioned again, external volumes is like the variable name, and we'll have multiple values in it. So we're just adding it. That means if two drives, the E comes in and then the F afterwards, they will both be in that variable name, right? It's a set. The completion of this logic that we're looking for is done here. So here we're saying we're doing another different rule, and we are looking for a new process. So process starting, an operator AND, which means we're going to. Okay, sorry about that. Disconnected for a second. So we will take two other operators and we will AND them together. So they both have to be true for us to match. And that will be the following. So the first one is we are saying, in this new process, I want to go in the path event file is signed. And if it is the value 0, which means this is not signed, so this is an unsigned process, pardon me, then we will take, so that will match. So, and here's looking at the other part. We'll go and take the file path in a non-case sensitive way. So that's a detail, just Windows. And we will say, if that file path starts with, and then we can see here's a new syntax. So this is the syntax for variables. In this case, you can kind of get the same vibe as the look back, right? It's very similar, but in this case, we're saying, I don't want to look back and compare it to another value in the event itself. I want to look it up against the values that I have in my variable. So I will use square brackets and say in external volumes. So if the file path starts with one of my external volumes, so E colon, I want this to match. So if this matches, that means, we have an exe starting, it is unsigned, and it is on the removable drive. And then I will respond and just say, generate an alert. Obviously, stating the obvious, but DNR rules support many different kinds of response. So, we saw report, which is generate an alert. We have a task to send a task to a sensor, but it could also be to tag that specific sensor. Like there's a bunch of things that you kind of could do around here. You could add a new variable, right? You could take now this exe path and stuff it in a new variable that's called unsigned removable processes. And then you could apply a different set of logic onto that. So you can see that, again, it's a theme in what we do, right? We always talk about the Lego blocks of security. We're not the widget that you can use in two different ways and like it will solve all your problems. Don't have to think about it. Those are pro tools, and you can start to see that with this, there's not a lot that you can't actually detect. And the beautiful part of it is that you can do that and you can customize it with your users. So we've seen people deploy into production environments, with hardware, machinery, and stuff like that, where it's such a specific environment that they're able to create dedicated rules that look exactly for what they know is an anomaly in that network. And that's something that you won't really be able to do with any other tool. So that is the variables. Let's look back at our at what we had here. All right, so we've talked about this. One thing I'll go back a little bit briefly on the resources. So as you may or may not be aware, so resources, we have lookups, but we have other kinds of resources. So you can often use them in a very similar way as a lookup. So a lookup is just, here's a list of things, right? It can be, you can look at the document. It can be JSON, new line formatted, MISP format, OTX. We support a bunch of different things. But it can also be an API. So for example, we have the VirusTotal API. So if you set your key in your organization, you can start to automatically do lookups against the VT API. So you can do that all from within Lima Charlie. We also have services. So some services expose lookups themselves. So like the OTX service allows you to not only scan kind of for everything you've got, but you can actually specify scanning for what specifically, which pulse, where you want to scan it, how you want to respond to it. The last topic of the intermediary would be the transforms, and then I will go into the advanced and we'll kind of get a little bit of a feel for it. So the transforms are fairly straightforward. Let me just all right, so we will switch back to the doc. Excellent. So the transforms are additional components that you can set with an operator. And what they're saying, they're transforming what the operator is looking at. So let's pick a basic example. I don't know if we have one here. Let's say, this is an example of on an artifact, but we're saying here this operator is saying, if the path in PDB contains this value, do something about it. But what if what's at PDB is not like a single value, but it's something bigger. So let's say it's either a file name or a file path, or it's a domain name. Sometimes you want your rule to say, let's pick the domain name example. You want your rule to apply to a whole top level domain, not just a specific domain name. So if your event is telling you, updates.evil.com as a DNS request, and really you're interested in blocking or talking about evil.com, you can't do a lookup on what was it, update.evil.com, on the list where you're holding, and maybe you have a lookup that's called evil.com, because they're not going to match. They're different. So you want to transform the value that is in the event and then apply your lookup on that. So the two main transforms I just mentioned, file name and subdomain. So um, the file name is kind of the easiest one of the bunch. The idea is I have a file path, and I'm only really interested in the file name of this. Sometimes, sure, you can use the ends with, but if you're comparing, a literal value against it, but sometimes you want to use it against a lookup. So let's say you're responding to an IR, a file name that's used by the attacker for their DLL, but it goes in random directories. One way you could do this is you could have a rule that says, take my event/file path of a new process, and I'm going to use the file name transform. So let me switch to code, because I think it'll be a little bit easier for people to just see. All right, let's make a new file. So transform.yaml. Alrighty. So maybe right, I would say, I have my path, which is event file path. And if I was like I was saying, if I was looking for literal, I could literally just say ends with evil.exe, and then my operator could be ends with, right? So if my path ends with evil.exe, but now let's say I have a bunch of those file names. I have like 100 of them. So I don't want to have 100 things. So I'm going to create the lookup, right? That I'm going to push to Lima Charlie. And I want to look the name against in that lookup. So my lookup is going to contain evil.exe, eviler.exe, I'm really evil.exe, like these kinds of things, right? So here, what we could do is we could say, okay, this is going to be a lookup. It's going to be in a resource, right? So LCR lookup mine. And then I'm going to say, so as it is right now, we take the file path. Is the whole path in that lookup? Probably not. Maybe it's in the user directory, which kind of messes up your whole thing because the user is going to change. So here you would say you use a transfer file name, true. So this is telling Lima Charlie, hey, take the file path, take whatever was here, but before looking it up, right, before feeding it into the operator, I want you to transform it, and I want you to go from, C users max evil.exe, and I want this to become evil.exe. Simple as that. So fairly straightforward. That's the file name operator. The other operator can be a bit more complex to use, or it's more customizable, right? File name is a file name kind of thing. The other transform is the subdomain. Can't remember if there's a space. There is a space. So subdomain, it will take a different type of value. So it's a slice notation. It might take you, if you haven't, done software development before, like it might take you a little bit to kind of grasp it. But essentially what you're doing is you're describing what part of the domain you're interested in. So let's say our domain is, this is my domain, right? This is what I'm seeing when I look up. And I'm only interested in getting this. So the slice note, alrighty, okay. So the slice notation is is where I will define the index that I want to, the index of the DNS component, the labels, I believe they're called in the protocol. So this is going to be 0, 1, 2, 3. So I will specify the start and end index that I'm interested in. And I'll do that separated by a colon. So in this case, if I want the last two, there's a shortcut I can use. So I can say -2 colon. And by not specifying the end index, that means all the way to the end. So this is going to take my, my full domain and extract and make it eviler.com. And that is what's going to go against my my lookup in this case. But you can use it in a bunch of like different operators. The idea is that this will really allow you to, maybe you're saying that you don't want anybody to access, again, like anything on like, the AWS delivery network, or like, 3322.org, just to pick a completely random example. So you can use that to actually describe the TLD itself, and then everything under will match. You could also use it for like, I don't know why, but I'm sure there's an interesting combination where you would say, let's say 1-1. So this would change it to, evil, right? If I changed it to 0-2, I would go from 0-1-2. So I would go, and that would become sum.evil. So you can see how you can kind of iterate from that. That's also a pretty useful one in combination with the string distance operator. So the Levenstein distance, which will tell you the how closely a string looks like to another string, the distance in number of letters. So the tip here is, let's say I'm corp.com, right? This is my corporate domain, and I want to see if anybody ever like registers some weird DNS that looks like corp.com. I could say a little bit like before, right? I could say -2 to 0. And then use a string distance, and then I forget the exact definition of it, but essentially you can say max of, let's say, 3 and a value of corp.com, something like that. It will actually look for any domains. So domain name, any domains. Their last two, the TLD, like the last two components of their DNS, and we'll look if it matches very closely to corp.com, right? Maybe the attacker decided to use corp.com, right? So the Levenstein distance, a string distance, is going to tell you, hey, with a single letter change here, you look like corp.com. This might be some kind of phishing. So that's a little bit of parenthesis. But it should give you an idea of like the amount of power of like all the things that you could do with Lima Charlie. And always also keep in mind that you can put rules that operate on detections from other rules. So you can also even kind of create levels of rules that describe very, very specific behavior, or tags from hosts, stuff like that. So I will go over the last bit, which is the stateful. I will go at a bit of a high level because this is it's kind of one of those that might take a little while of like practice to really get into it, and I want to make sure that we get to to questions if there are any. With that in mind, let's go to the stateful aspect of things. So let me just see if I had anything useful here to discuss about stateful. Not really. Okay. So What is stateful? Um, I will switch to our doc. All right. So in the doc, you'll see we have stateful. I mentioned this is kind of it looks similar to DNR rules, and it's again in the same space and everything. But it does a ton of magic for you in the back end with regards to keeping track of the relationship between things. Pardon me. So the main two ways that you can tell, hey, this is a stateful rule, is by the use of one of two operators. So, or not operators, but rather parameters in a rule. So you will see the with child and with descendant statements. They effectively allow you to describe the relationship between a first event and the relationship between that first event and a subsequent event that is related to it. Again, I'll explain more. The distinction between the two is that with child is a direct relationship. So this event is my child, meaning, one created two. The with descendant is an n level descendant. So that means one could have created two, that created three, that created four, and four is what I'm interested in. So there's a descendant relationship all the way in there, but it's not just one level. It can be any number of levels. So the easiest way to usually kind of start thinking about it is with processes, right? Because that's the easiest relationship you can think of. A process starting another process. In this case, here's an example rule, right? Where again, this looks very, very familiar. This is a normal stateless rule, right? If a new process with a file path ending in command.exe ends with a value, ends with the value command.exe, then the first part here will match. But we have the with child clause right below. The with child clause is telling the engine, hey, whenever there's a match on this first part, I want you to remember this match. And if you see an event that is a child of that event that matched, and that child matches this other set of stuff, then that's a detection. So in this case, that other set of stuff is just another stateless rule, right? So here we're saying with child, and then it's a new process with a file path ends with calc.exe. So the net effect is we will match if a command.exe spawns a calc.exe, but we will not match if command.exe spawns a firefox.exe that then goes to calc.exe. Why? Because it's with child, not with descendant. So if you switch that to descendant, then you get, as far as the eye can see, like any number of relationship. So here's an example actually of this. So we could, add other steps with descendant and that would match. The with child and with descendant support the same rule set as the stateless rules, like the same depth. So in this case, you can see that the characteristics to match below a child can be complex. So here I'm using an and. So I'm ending. So if it's chrome.exe, right. So yes. So let me rephrase this. The with child, everything under the with child doesn't have to apply to a single event. It can apply to any number of events as long as they're all the child of that same root event. So here's an example of that. I have outlook.exe, so I'm looking for Outlook. if it has a child uh, and it has a child that ends with chrome.exe. So if my Outlook spawns a chrome.exe, and if my outlook.exe creates a new document that ends with ps1, which is a PowerShell script, I want this to match. It does. So the starting nucleus of this rule is the outlook.exe, right? That's the scope of my detection. But the end here will apply to all of the children events of my outlook.exe. So I could have a Outlook start. 2 minutes later, I could have Chrome start, and then an hour later, it writes a document. The Outlook writes a document that would match. So there's a way to have multiple clauses, like multiple operators relate to the same thing, and that would be with the is stateless statement. So you can kind of in those stateful statements you can add is stateless, and from that point on, then they all apply to the same event. I'll kind of let you read through those. The last part that I'll mention is that the stateful operators also have things like count and I believe it's within. That's mentioned somewhere. Yes, within. So these will allow you to say, if it spawns chrome.exe 3 times. So count the number of times and only match after that number of times. The within allows you to say within 5 seconds if it does the following things. So that allows you to put some time bounds against those as well. So I will kind of leave it at that. There's we really got into that stateful stuff. There's a lot of much more advanced kind of topic there, but I think for a webinar it's kind of a good place to stop. So I see some questions, so we'll just look at those. And yes, feel free to put in your questions. So can we write a rule to detect an unsigned executable spawning from PowerShell? Yes. Yes. So something like that would look actually, in a way, like quite similar to the stateful stuff that we have here. So to spawn, to detect an unsigned executable from a PowerShell, your stateful rule would say, the nucleus of the rule is find PowerShell executed, right? And then you would say with child, assuming you want to look at, one level, with child, you would have then an operator that says, I'm looking for a new process with a value of event slash file is file signed of 0. And then that rule would do what you described, right? It would look for a PowerShell, then it would keep it in mind. If it ever sees an executable that is spawned by PowerShell, it would look at it, say, is it unsigned? Yes. Okay, this is a match, and it would report that. Is Lima Charlie coming with some set of built-in detection rules? So yes and no. So by default, if you create an organization, right, that's like our basic unit of structure, that's like a project in AWS or Google Cloud Platform. By default, it has nothing. It's a blank slate. It's kind of there on purpose. We support a ton of things like infrastructure as code. So we put a lot of emphasis to make it easy if you're an MSSP or somebody, like that, to replicate environment, keep track of it, and like config files, all that good stuff. So that's the no part. The yes part is that we have a few different services as well as detection rules that are available in the marketplace on Lima Charlie. So if you go in the add-ons section, you'll see there's a few. So some of them are very threat feed centric. So let's say the OTX balls. Some of them are individual detections, so individual rules that people have posted. And you can use those. In the case of individual ones, you can subscribe to them, and then you can create a rule yourself that says where to apply it. In case of services, when you subscribe to it, it gets applied automatically to your organization. You will not see the rules that it creates. That's kind of the design to allow people to create feeds that they can then monetize through your platform and things like that. So you won't see the rules, but they'll get created for you, and you'll start seeing the detections coming through. And the best example of that would be the Soteria rules, which Soteria is an American MSSP that amongst many other things produces a really thorough set of Lima Charlie rules. So they've built those for a long time for their own purposes. They cover all the platform, a ton of different types of attacks. They're documenting that process, kind of continuously working. They have a white paper that they've actually published recently. So I would say that's kind of the most comprehensive way to get started quickly. By subscribing to that one service, you kind of get all their rules set and managed for you. So they update it always. The other one of interest is Sigma. So Sigma is an open source set of rules that's part of a project to apply those rules to a bunch of different search products. And we support it, we mirror it within Lima Charlie. So if you subscribe to the Sigma service for free, we will take the biggest part of the Sigma rules and apply them automatically for you. Keep in mind that it's an open source generic kind of set of rules, so you will definitely get kind of a lot of what you might consider false positives. So you'll have to write some of those. And I see somebody posted the white paper. Thank you. Yeah. Any other questions, thoughts? If not, that's fine. If you're shy in this webinar, feel free to reach out to us. If I recall, we also have slack.limacharlie.io if you want to go and kind of directly join our Slack community. So it's kind of a quick way to get your own, generate your own invitation there. Yeah, and if you have thoughts around operators or things that we could add to the rules, I know recently we've talked to some people that were looking at doing lookups at a very large scale. So the engine that the DNR rule engine targets wire speed. So everything you saw here, it doesn't happen in a batch every 2 minutes or anything like that. This is wire speed stuff. So that means you can detect and kill something in about 100 milliseconds. But some people have requested kind of ideas around doing multi-gigabyte lookups. So that's kind of the type of thing that we're interested in, maybe in the longer term. It's kind of a different mode of doing things. Obviously, we can't really do that at wire speed from memory. But there's a lot of interesting things there. The other part is that, as a bit of a preview, we are in the process of in beta for some of our upcoming products around cooperation around management of events, but more importantly as well is the instrumented VPN technology. So you will be able to kind of do firewall in the cloud per device, to do Suricata per device in the cloud, all kinds of things. So a user asks how many values can be contained in a variable and for how long. I don't remember the exact figure, but generally we structure those things to be at a size where you will never actually hit it. And if you hit it, it's likely an error, or you're doing something where there's a better way of doing it. So if you do hit it, let us know. But it's probably in the order of a few hundred kind of thing. So in terms of time, I believe that the only time limitation there is if it's not touched within a very long amount of time. Meaning, if you have a sensor that created a bunch of variables, and then that sensor maybe got reimaged, so it's gone. It's never coming back. After 6 months, maybe something like that, we will probably just drop it from the back end. Cool. Well, it looks like we're pretty much right on the time. So thank you very much. It's really exciting for us to share these. We are also building more courses at edu.limacharlie.io, where we'll be posting additional structured way of learning a lot of the capabilities in LC, because we recognize that we have a lot more capabilities than what's actually easy for people to digest and get in. So keep looking for that, and yeah,